Good evening, everyone, and welcome to a Sydney Reactor live stream. My name is Nadia, and I will be moderating and producing the session for you all today. And I am joined with Michael, who will be taking us through the session today, which is Tokenise All things with Azure Blockchain. So if you have any questions, please put them in the Q&A box and we'll be able to answer them. Good evening, everyone. And without further ado, I'm going to hand you over to Michael. Thanks, Michael.
Thank you very much, Nadia, for the introduction. Hi, everyone. I'm Michael, and let me share my screen. All right. And also, yep. Sorry, just gonna remove my video. Although my my background is inspired of the topic, Minecraft and blocks. Okay. Cool. Let's start. All right. So for today, we're gonna talk about more around blockchain and a little bit of Azure, or more or less like getting started with Azure as well in terms of this space. A little bit about me is that I've been in this space, blockchain, for I would say quite a while. Around 2012, 2011, late 2011, that's when I got my interest around this space. 2012, 2013, that's kind of when it becomes much more technically interesting. And around 2016 to 2018 and early 2019, that's where a lot of the hype and buzz around blockchain came to be. I'm a father, also Microsoft MVP for Azure, and I run my own blockchain and AI consulting company called Data Chain Consulting. For today, we're gonna cover, just a simple blockchain 101. Some of you here might be very familiar with this, just for the sake of everyone, so that I'll try my best to simplify, the topic. That's often, have a lot of different interpretations and meaning and descriptions. And in this particular talk, right, I would like to focus on tokens, right? Although there's so much thing to cover in terms of what Azure is doing, what blockchain is, and those different technologies and concepts around it. But I will solely focus on tokens around this space. All right. But to start off, the way I approach, and when I talk to business around this, right? If I'm talking to someone on sales or someone who's on the leadership team with a little bit of background technically, but at the same time wants to, get the gist of why would you actually need blockchain in the first place. I always start with, to say that it's literally just a mechanism, to exchange values when some of the parties don't trust each other. Most often than not, it's probably a product of different batch processes, database exports, CSV exports, and reconciliations from different subsystems or different systems. And they kind of like want to have a source of truth, but at the same time, no central party who's kind of like be on blame of that data, because it's eventually a shared responsibility across the different groups. Think of it like the companies or the groups or the businesses are sort of creating a club, like a organization, or probably a much better term is a consensus amongst them, that no one kind of like holds the data on an infrastructure level and on a responsibility or governance level as well. But at the same time, everyone trusts the data to a certain extent, and everyone trusts the validity and the security around how the data is represented. However, when I talk to people who's into technology, or after how to actually implement blockchain, or how to get started, or what are the technicalities involved. I always start with like most of the time I tell them that it's nothing really fancy in terms of on how it works technically, because it's a distributed ledger technology. If you've been into the space of messaging and those distributed systems, most of the concepts are very much inspired out of it. And I think the key concept there is that instead of having a centralized database, the infrastructure is often, not all the time, decentralized, and have a concept of different nodes, maybe owned by different parties. Um, yeah, and that's pretty much it. Like instead of really having one database that everyone consumes via API, or through gRPC or any sort of web endpoint. Um, yeah, you basically have a concept of a distributed ledger. And the way where the development work happens is through the concept of having smart contracts, which is not smart, and it's also not also a contract, but basically it's what define custom logics. Like those who have programming background, it's basically like a class that you actually deploy, and that class have a set of behaviors, properties that you kind of want to enforce as a means of policy when you do exchange data, or when you exchange value. And the last part is more around like a debate of what makes it unique, or what makes it secure, or what makes it tamper proof, what makes it a valid data. It's the concept of consensus algorithm. Proof of work is something that Bitcoin and other cryptocurrencies adapt. It's basically saying that all the nodes all over the world should agree, and there's a proof that the work has happened and it's been mined and recognized by all the nodes. Hence, it's much more expensive, but at the same time, the validity or the trust is much more accepted. Unlike in proof of stake, wherein it's more around who's actually at stake of that data, and who actually have a governance, or who is actually involved in the relevance of that data. And there are more consensus algorithms that's been developed, and most of them are tied into a use case or a business use case that defines relationships between those club members, those parties. Yeah, that's pretty much it, really, in terms of explaining blockchain in a tech nutshell. But something that's really dear to my heart is the concept of tokens. When this started, the immediate use case was cryptocurrency, because having a digital representation of money is something very business viable, and something I would say there's an there's an actual value out of it, because it's money. But throughout the years, it has evolved into different use cases, and basically at this point, anything can really be a token. And I'm actually very lucky to be exposed in this space, and have seen different use cases on how they adopt or how they tokenize things on their businesses or on their end. In particular, like besides the cryptocurrencies, coins, or yield farming and that kind of stuff, something that really catches my eye is a concept of hybrid tokens, which I'll take on later on. But think of it, right, that a house, a land, jewelries, or any sort of item, even cattle and cheese, wine, they can be tokens. And what's interesting around it is that if you think about spaghetti, you can actually treat it as a single token. But what composes spaghetti or any other food really is composed of different ingredients, which are also tokens of its own, and that ingredient could be a byproduct of another something, which could also be a token. Hence, my experience around this supply chain is, I would say this is a spot-on use case of blockchain, because I've seen a lot of use cases here and then that really make sense within supply chain. Some of the examples would be uniquely identifying bags. Most of them are doing, cold chains, making sure that temperatures are met when it leaves the country or when it goes from one destination to the other, as well as having proof of delivery when, transport happened, and, it comes from, let's say, from a farm to an abattoir to a product and that kind of stuff. And even probably the very unique use case I've seen, which I think is a very high valued use case, is in a concept of bonds or contracts, wherein there's this small farm who can actually, kind of like loan to a bank because they have a contract that, hey, basically, abattoir ABC is requiring 10,000 cattle from me. And so I sort of like have that contract that says abattoir ABC wants, that 10,000, and I need to produce that 10,000 cattle in, let's say, 6 months time or a year's time. And sometimes that farm needs extra help in terms of money, so that they can actually sustain. Maybe they need to purchase more land or more supplies. Yeah, really interesting use case around that. And that bond, that contract can also be a token. So everything can be a token. What kind of defines a token in the blockchain sense really is about the cryptography and immutability around it, that basically defines that this token is unique or exchangeable, and those different inhibited properties or behaviors, and having a concept of addresses, wallets, that kind of ensures that hey, this is valid. Like my one token here is mine. It's not yours. It's not something someone can just replicate, right? So in a case of provenance problems in supply chain, even though you have a QR code, you can just copy paste the QR code and produce it and print it, right? But the actual identifier of that token, or quote unquote that bag or box, can be traced back to the owner, and you can actually see who owns it and who has the right out of this asset. So mainly there are three types of tokens. First off is the fungible token, which is very common in cryptocurrency. Basically, think of it like the fiat money, and that kind of idea that 20, like for example, the $20 bill is equivalent to $21 coin. So you have that accepted value amongst that currency, and that defines the fungibility of that token. And there's a uniform specification, and it's divisible, I would say. For example, that $20 bill can be divided into two $10 bill. Then some of the common standards are ERC20, which is specific for Ethereum. The other type of token is non-fungible token, which is much more appropriate for the use case of asset chain and supply chain, wherein you treat each and every item as unique, and they are not interchangeable, although they might mean the same thing. So what that would mean is that, for example, in the use case again of supply chain, maybe there's a lamb with an identifier of 1, 2, 3. Although it can be replaced with a lamb 3, 4, 5 because they're literally the same. I mean, they are both lambs. But since you've uniquely identified lamb 1, 2, 3, and it may have some properties of its own, it can't be replaced by lamb 3, 4, 5. Just like your pets, high valued paintings, although you can create a replica of that painting, the original painting is still the original. And non-divisible, but some hybrids can. I'll talk to that one later on. And the common standard for NFTs are ERC 721, which is highly adopted if you're into CryptoKitties and that kind of space. They're one of the biggest driver of this standard. The next one is the hybrid tokens, which is again something I would say gained more traction in the past few years, and this is where more serious development or more serious business use cases really happened. Because back then it's either just a fungible or non-fungible, but now it becomes much more robust or much more flexible. Especially in B2B scenarios. So basically, a hybrid token could be a multi-token standard, wherein it can be a mix of the both worlds, and you can create some very complex relationships. So I'll give you back an example of the example I had earlier with spaghetti. So with spaghetti, maybe it might be composed of meat, noodle, and sauce. And in that meat, you purchase it from, let's say, supermarket one. Then a noodle is something you purchase from another supermarket, and so on with the sauce. But the fun thing about this concept is that maybe you can track it all the way back to knowing which cow was it produced from, and which egg, or at least which chicken farm it came from, or which yielding farm for the tomato it came from. So that concept is rapidly evolving lately, and that's something I'm very I would say passionate, and at the same time really into that space in terms of business use cases. So really very interesting about tokens. That's why it's I always advocate that tokens are not just about cryptocurrencies. There are a lot of use cases around it. You just need to properly define them. And speaking of definition, so now we have a concept of token taxonomy, and basically it's much more like yet again a standard similar to an ERC, but this one is not ledger specific, unlike ERC, which is more around Ethereum. And if you want to learn more, there's that website. But basically a token taxonomy is, if you're into programming, it's like an interface wherein you can define properties, behaviors. Like for example, in the example, I'll give you a very good example. Let's say in cattle, or like beef, chicken, or any sort of like protein industry. It's often mintable, meaning you can create a new token because a cow or a lamb is always born. It's burnable, but probably burnable is not a good term for it because people consume that product. It's subdividable because when you actually capture it from an animal and turning it into a meat, it becomes subdividable. It's transferable either as a whole calf, or it could be transferred as a bag, or it could be transferred as a raw meat or anything like that. Then you can have different role-based access control around it, wherein let's say you only make sure that this address or this party is the one who can split, or who can, mint that calf. And you can also set an expiration and suspendable. Let's say there's a product recall, you can suspend all of them, ensuring that you mark all of them as invalid tokens and not in circulation anymore. Um, so what's out there? I would say in terms of technology, first off, there are a lot of ledgers out there. Ethereum is one of them. In terms of programming language, working on Ethereum, Solidity is the most popular one. In terms of local development, Ganesh, Truffle, and the whole suite is also very popular. Having a concept of wallet, a decentralized wallet, MetaMask is mostly popular. And in terms of development environment, I think VS Code really is doing a lot of work around it, and that's where my demo later on would come in with this set of tools. All right, I'll do a quick demo. This demo is pre-recorded, mainly so that I won't be sharing a lot of credentials or secrets and tokens and stuff like that. Yeah. All right, so off we go with demo one. All right, so on actually before I go there, I think before you go to VS Code, or this is the extension that's really very useful, especially when you're starting off, because the blockchain development kit for Ethereum allows you to do a lot of stuff, which I'll cover in the demo. But in a nutshell, basically what it does, it does all the scaffolding for you, and mostly create that UI environment to get started pretty quickly. All right. All right. So on VS Code, once you got that extension installed, you will see that blockchain network tab over there, which allows you to either connect to an existing Ethereum network, or it allows you to create a local network, or it allows you to create a new network on Azure using Azure Blockchain Service. Yeah, and it's very straightforward. It's all GUI from there on. All right. Then that extension also comes with a lot of commandlets for VS Code that allows you to create new projects. Start the local server, stop the Ganesh local server, and stuff like that. And basically, just click on Start New Project, and it will create that project on your folder. All right. It's going to create the contracts folder, which contains all the just a simple hello world contract, as well as migrations, which is literally just a script that allows you to migrate that contract from a source code all the way to an environment such as the local machine or Azure. And another cool thing about this extension is that it allows you to create tokens on the fly using templates from OpenZeppelin. And it allows you to define as well, like, what will be the token name. I named this as Reactor token, and other, metadata around it is something you can just define. All right, there you go. Just from that one, you now have an ERC721 or an NFT token. And it also generates that script for you that allows you to bundle in not just the actual ERC721 contract, but all the other dependencies around it, SafeMat, addresses, counters, and whatnot. And something I just did here is that I extended that contract to also use the mintable contracts so that I can generate a token on the fly. And I'm going to interface locally on the local development. And from there on, I'll literally just, type migrate. And it's going to compile all the smart contracts for me, and it's going to deploy to my local development environment. All right. One thing to note, especially later on, is you need to understand the contract address of the token that you've launched. All right. All right. So from there on, what I did is still using the Truffle console. I just interface directly through I interface directly through the contract that I deployed through locally. Then from here on, what I did is that I'm using MetaMask to create a local wallet or a wallet that interfaces against localhost 8545, wherein that's where my local development environment is. That's something you also set when you create that local environment, or you can set it on using different tools as well, such as the Ganesh platform or the Ganesh CLI. So what I'm basically doing here is that what I would just like to show is that from here on, right, that instance itself, you can just mint. Mint meaning you create a new token and send it to that address. All right. So from there on, what I just did is that I minted a new token, which has an ID of 7001. That token 7001 is unique and something that you can just integrate elsewhere, wherein that 7001 could represent anything. All right. Then from one RTC, you now have two RTCs. Yeah. Then what I want to do next is I just want to do a quick transfer from this address to the other address. Yeah. So basically, that address usually defines either a person or an entity, such as a business, or in some cases even a location. Like for example, a business have multiple locations, so you can uniquely identify where a token is currently stored. It's more or less like a representation of what's happening in the real world. So in the real world, what could happen here is that let's say from the farm going to a truck, what could happen is that this could be the address of the farm and this could be the address of the truck, wherein you do a transfer from the farm to the truck, and they have different unique addresses. And 7001 is, let's say, cattle 7001, and from there on, you can basically say, hey, it's not within the custody of farm anymore. It's now in the truck, and that's where you can also implement different smart contracts to kind of like define um, yeah, to kind of like define the business rules around it. Let's say most often than not, the usual use case around here is that there needs to be a proof of signature, or there needs to be a photo, and that photo will is stored on a blob storage somewhere, and you have a reference out of it. But then the actual transfer as you might have seen previously, it generates a unique transaction hash, and that transaction hash can create, a reference off the chain, which is from the web app that, hey, this transaction happened between address 1 to address 2. All right. So how about, where does Microsoft Azure really comes in here? One thing that, like I've seen, outside of Microsoft, right, is that Azure is probably one of the early game players on this space. Um, they've started with having a lot of virtual machine templates, such as, Ethereum, and any other sort of like ledger, and as well as other integration points such as an explorer and all those kind of stuff. It's something highly available in Azure. In particular, if we actually go to the portal now, right, and if we create a new resource and just go to the blockchain tab, you'll see a lot of pre-made templates around here. Right, you have the Ethereum proof of authority, which was something very popular back then. Even create your own quorum network, as well as Hyperledger Fabric. And again, no one's stopping you to just spin up a Linux server, right, and just install the dependencies yourself. Back in 2000, I think 15, that's what was the normal thing back then before all these templates came to be. All right. But something that the team in Azure, or the blockchain team in Azure kind of really focused on is the Azure Blockchain Service, which is a managed instance of a blockchain network, which basically allows you, I would say, for three different reasons. First, it allows you to really get started very easily. It allows you to set up a multiple nodes, or having that consortium in just a matter of minutes, instead of spending back then to spend days or even weeks just to set up the environment. I still do remember back then that even the networking side of things between nodes on a private, on a consortium, not the decentralized public blockchain. I still remember it took us days really to get that up and running before we can actually have a distributed ledger setup. The other thing that they focused on is integration with off the chain data, because I think they've understood right from the beginning that it's either a lot of companies already have off the chain data, meaning like databases, storage, and some specific data just needs to be on the blockchain. And and the other one is that I think they've also understood right from the beginning that there are only specific use cases that really spots on blockchain, and not all the data can really be reasonably placed on the blockchain. Especially large files, and sort of like things that are not really relevant for everyone. Like for example, personal identifiable data. It's usually not stored on a blockchain. It's usually something that's managed by a member, but then that person can probably be represented into an address. So those kind of stuff, I think having that managed platform really allows you to separate what's on the blockchain and what's outside of blockchain. And in particular, I did like the blockchain data manager, which allows you to like have that sort of like a messaging queue of some sort that allows you to listen from the blockchain network. Then It sorts of like represent data from the blockchain instead of hitting the blockchain all the time directly from the web app. Some read-only processes can readily be available and much more efficient to be performed on a database. All right. So on my demo too, I'll just quickly show same example, but just how easy it is to get started on Azure Blockchain service. All right. So on your Azure portal, literally just go to the blockchain section, click on Azure Blockchain service, choose a resource group, choose a region. Right now they only support Quorum, but a lot of other ledgers are on the way. Then you create a consortium. In this case, I named it as Reactor Universe. I usually use the analogy of universe as a consortium. Then in terms of members, I usually name them as galaxies, but it's up to you on how you really want to create those analogy. But the whole idea here is that the consortium is the group or the group of all the parties involved. And the member detail here is just the starting member. In this case, your member or your galaxy or your planet or anything like that. Then you set a password and choose pricing and the node password as well. All right. But I've already created one. All right, which is in here. All right, so basically from here on, you already have a managed platform, really. You don't need to worry about CPU usage or memory and stuff like that. What you could probably do once you hit that certain performance issues, you could just add new nodes. Or again, just like what I mentioned earlier, is you probably might want to use Blockchain Data Manager to handle that off-chain data for you. All right. So with the same example, basically, with the same Visual Studio extension, this allows you to connect to Azure Blockchain Service straight away. Or you can create this Azure Blockchain Service straight from VS Code instead of doing it in the portal. Up to you on which one would you prefer. Right, allows you to connect to a network. Then once you've connected to that network, it establishes a connection between your solution folder, which gives you a mnemonic or a key that basically provides you capability to interface through it and allows you to deploy contracts to it as well. So very similar process, but this time just open the truffle config, which basically once you've connected it, it allows you to give you a network or the endpoint where it's going to connect. Okay. All right. So basically same process, but instead of doing it locally, you go straight directly and deploy the smart contracts to Azure Blockchain Service. Right. So you might actually notice here that it's quite slower rather than locally for obvious reasons. But at the same time, what's kind of different here is that it's basically happening to a network that is going to be recognized by the whole consortium, right? It's basically not just one machine trying to recognize this. That's what I'm saying. So hence that kind of delay you might experience. And most of the time, that's usually the questions that's being asked to me. Hey Michael, how can we actually make minting faster, or how can we make transfer faster? Right now we're hitting at 16 seconds or 20 seconds to do a transfer. That kind of scenarios. And there are again many factors that drives it, but mainly because one is probably the source code or the contract size is kind of big. Two, maybe some addresses. Sorry, the some properties are overloaded. Like for example, you define a lot of thing on one token, and lastly, network wise, maybe you just need to you know change from VPN to Express route and those kind of stuff. Um, so many factors to consider, really. But then again, using ABS, using Truffle, using BS Code, it's very easy to get started. By the way, this one is really just for demo, but in most of the time, there's a much better or a sophisticated way of doing this. It's probably through a DevOps pipeline, wherein you can establish, whenever someone changed the code, when someone accepted that pull request and stuff, that's when you actually do a deployment to ABS or Azure Blockchain Service. However, something that's kind of tricky there is that you need to remember that contracts are immutable, and that means each time you do an update, it's a new contract of its own. So yeah, this one returned an error because it was expecting a result, but all is fine because the contract was successfully deployed. There you go. Total deployments. All right. Okay, so once the contracts were deployed, all right. So now using the same exercise, but this time, what you might probably notice is that instead of just doing it through localhost, I'm now connected to a custom endpoint. Yep. It's a custom RPC point, which you can actually see inside the node of your Azure Blockchain service. If you go to ABS, then go to transaction nodes, and go to that node, then go to connection string. There you go. That's what the custom RPC endpoint is for you to connect to MetaMask. All right. Then from there, you can, just again, do the same exercise of minting, and basically, create that token for you. That again, token can be represented somewhere else. That could mean, a cattle, that could mean a diamond, or that could mean a property, or any sort of really representation of what you want. You've probably noticed that delay over there. That's what I was saying earlier. Wherein basically it needs to ensure that all the members agree what data is being inserted on each and different blocks, to make sure that, hey, this is a permanent record now, and everyone agrees. And it's even gonna get slower if there are more members involved and more transactions happening in real time. So just again, point of consideration, set some realistic expectations on what is acceptable in terms of speed and performance. And that's why having the right architecture and having that right setting up and different techniques allows you to become much more efficient. Yeah. So for this one, same thing. I'll just mint another token. And there you go. If you do a refresh, it's gonna take some time. All right, there you go. Probably after 7 seconds, that's when it becomes recognized. One thing I would just like to show you is that since I'm already here, right? If I do the same minting with the same token ID here, you will actually see that it's gonna complain, basically saying that token is already minted. And that's what really is a smart contract, right? That you just need to define which kind of like behavior you want to pursue. Like for example, I also want to do a let's say a transfer from the same thing, right? Like from one address to another address. It's also going to complain. All right, because basically the transfer caller is not owner nor approved. So again, you can have those different rules that you want to implement. And yeah, really, it's very easy to get started. So yeah, getting started is very easy. A lot of tools are available now, and there are a lot of pre-made templates and standards. But lastly, what I would probably say is that the key factor around this is that adoption. Without real adoption, these are all just fancy games. That's why having the right use case is really what drives adoption and what drives business value. Um, yeah, that's pretty much it. I guess Nadia, we have 12 more minutes remaining. I Yeah, I guess open
Sure,
for questions or
we've
anything
got
like
a
that.
few questions that have come through. So the first one is, what are some other ways tokens can be used rather than payments?
Oh yes. Again, I've mentioned earlier, I'm very passionate about tokens outside of the currency or payment space. Again, anything that you can think of can be represented of a token, both physically or even imaginatively or just virtually. That can be a token. So rewards points can be tokens. Bonds can be tokens. Kettles, anything you see on a supermarket can be a token. Anything that actually defines a value for someone, I think that can be a token. That's my perspective around it.
Cool. Could you explain why blockchain needs tokens to operate?
All right. So why do we need tokens for blockchain to operate? Okay. Um, I would say, right, if we don't have a concept of tokens on blockchain, what we have is a data storage, right? No one's stopping us to not use tokens. Maybe we just need to store a message and retrieve that message elsewhere, right? But what basically a token is that it's something that's represented intrinsically across the members that defines something, right? Think of it like a representation of something that every one of you kind of agrees on, right? What is a cattle? What is a wine? What is a cheese? What is this? What is that? Something kind of unique, and that's kind of like drives the business value or an exchange really across different members. So other examples would be trading cards, wherein you can have unique numbers or unique identifiers for those trading cards represented as a token, and you can exchange them virtually.
Cool. The next one is, are you able to elaborate on the Azure Blockchain service Microsoft has?
Sure. Okay. All right. So basically, just like I mentioned earlier, let me just go to. Right. Let me just go back here. All right. Sorry. Create a resource. All right. So, again, first off, there are many things Azure already provides in the blockchain space. One is all of those pre-made templates or images, of, if you may, or predefined set of pre-installed dependencies. That's one thing, but the a more abstracted or a more managed platform that they've created is called Azure Blockchain Service, which instead of spinning up multiple virtual machines, right? You have a managed platform that does have the capability of having a consortium. Just think of it. I think the best analogy around it is that um, if you want to create an intranet site, like SharePoint or anything like that, that a select group of people can collaborate with, Azure Blockchain Service allows you to do that quite easily, because from there on, once you've created the consortium, everyone can just be a member. Everyone can just create members and be part of it. So that's something managed for you, instead of company A set up 10 virtual machines, company B set up another 10 virtual machines, and company C set up another 10 virtual machines. And we need to make sure every one of them understand each other. Like, we assign how many are, um, you know, we're, members, and how many of them are kind of like used to store the data, and how many of them will be used for in terms of governance and those kind of definition. So again, ABS just makes that easier for you. It's a managed platform. However, something that this could be probably improved on eventually is, maybe there's a better way to manage the costs around it, wherein maybe you can share or split the cost across different tenants or across different subscription, which you can't right now.
Cool. I've also added a link to Microsoft Docs as well for whoever's asked that question, just to give you a bit more information around Azure Blockchain Services. All right, we've got another question from Pedro. What do you think of the increasing size of the blockchain Ethereum? Now it's 400 gigs and will increase more in the future, requiring more power for the computers to use it.
Oh, all right. It's a highly debatable topic. Thanks for asking that, Pedro. And also, again, it also depends on which side are you following on right now, and which sort of like principle. I think we've now come to that point lately, right? It's not just merely about which technology to use or which ledger to use. It's also now about principles on how do you actually define what's decentralized, what's not decentralized. Because like, for example, in other more purist side of blockchain, having it on cloud is not decentralized in the first place. There are those principles that basically tells them that once it's on a platform that's not something yours to manage, it's probably not decentralized in the first place. So to answer the question around that 400 gig and expanding, my vision, right, or my hope of where this is going is that, first off, I don't really want one ledger to kind of like rule everything. The way I want this to happen is that it's more around interoperability across different ledgers. Maybe there are those specific use cases that are really meant for the public blockchain that everyone needs to recognize, and hence we appreciate the power requirement it needs and the cost associated with it. But at the same time, in my perspective, there should also be bridges between those consortiums and connecting it to the public blockchains. And again, the public blockchains, a lot of improvements can be done on that space, whether we adapt a new protocol, we dramatically increase power in terms of computational techniques. Maybe GPUs, FPGAs becomes more cheaper and becomes much more efficient. Yeah, so many things that could drive it. That's the way I'm seeing it. It's like right now, how big is the internet, right? It's not just 400 gigabytes, but the internet is not just stored in one country. It's stored all over the world. So the way I'm seeing it is that it should be the same eventually, right? With blockchains, there will be many blockchains. There will be a lot of ledgers. There will be a lot of interconnected nodes and networks. It's just which are relevant to which.
Cool. All right, we've got a two-part question from Mitch. The first part is, what are the cybersecurity concerns to consider when developing private and or public chains? And the second part to that question is, and will we start to see low-code versions of what was just shown, for example, Flow or Power Automate being a managed platform?
Okay, so it's probably easier to answer the second one because the answer is yes. Because the problem I've seen on blockchain specifically is that it's not very how do I say it, like there's a big bridge that you have to cross in order to fully understand this space. There's that big gap that you need to unlearn in order to learn around it, right? And I think that whole tool set is really becoming more alive. Azure Blockchain Service is one part of it. You can now interface directly through logic apps using connectors, and nothing is stopping you to extend that through Power Apps, Flow, Automate, and that kind of stuff, right? But then again, by principle, right? If you treat it that way, that means that from logic apps onwards, it's hosted somewhere and another party is responsible for it, right? It's not a data that you can sort of like secure, or kind of like not really secure, but more or less decentralized in a way that it's not stored on one tenant or one party, because it is, right? It's most probably that you're saving it to another platform or database. And to answer the first question, right, I guess it's a matter of understanding those different layers on how much you want it to be decentralized and how much you want it to be hybrid centralized at the same time. And obviously security is a very big topic of its own. For example, one key aspect that I've encountered is that some requirements requires virtual networks. Hence, those RPC endpoints can just be something you can access through the public internet. That's one front. The second part is the wallets. Would you trust people to remember their own private keys, and that private key will forever be gone unless someone unless you've written it somewhere? Or would you want it to be managed and you tie it with a identity provider, but then that basically means that the identity or the actual private key is stored onto that key value pair for that identity ID. So there's that different layers or different considerations, I would say, on how much you want to empower users to be fully decentralized, or how much do you want it to be managed wherein even the end users doesn't even care or doesn't even know that, hey, we're actually using blockchain. So it's, again, the balance across that.
Awesome. That's all the questions we have at the moment. I'm just going to do a quick update for everyone just on the Reactor, some events that are up and coming. And if you want to ask questions within that time, feel free to as well, and we can do that. So thank you all for joining us this evening. If you want to see some more events that we do have up and coming, you can follow us on our Reactor meetup page, meetup.com/Microsoft Reactor Sydney. You can also follow us on Twitter, and you can also find a lot of our content up there on YouTube. If you've got any questions about the Microsoft Reactor, you kind of want to find out a little bit more about what we do, feel free to email us at reactorset@microsoft.com. Another thing I would like to add is if you've got any feedback on this session, you want to see more around Azure Blockchain, you want to hear more from Michael, feel free to leave us some feedback in the survey. I have popped that in the Q&A as well for everyone. And just if you could please enter the event code 11737, just so that we know that this is tailored to this workshop. So up and coming on Thursday, this coming Thursday, we have an intro to Azure DevOps. So DevOps brings people and processes and tech together, and using Azure DevOps, you can deploy and deliver infrastructure and software a lot more reliably. And the session is just going to show you how. So it's a very good beginner workshop. We've also got another session next week, which is Intro to Microsoft Learn How to Prepare for Certification. So we'll be joined by Lisa Crosby, who's going to take us through what Microsoft Learn is and how we can use the tools and all the presentations and everything to get certified with Microsoft. As well, next week, we have another new session. Another session is a thought leadership series. So we're going to bring you 3 of our well-known Microsoft regional directors who will be having a panel discussion around how to remain relevant in a virtual world. So you can come by and ask a whole bunch of questions to some experts, get their perspective on everything. So that would be next Thursday at 4 p.m. So you can RSVP for all these events as well on our meetup page. So as mentioned before, check us out on Meetup, join our community. You can also sign up for our monthly newsletter as well at aka.ms/reactor email sign up. So I don't see any other questions that have come through. So I want to say a big thank you to everyone who joined us this evening, and a huge thank you to Michael as well for taking his time out to take us through his session this evening. So,
Thanks very much.
Awesome. It was great. I hope you had a good time. Enjoy the rest of your night if you're calling in from the APAC region, or enjoy the rest of your day if you're calling in from somewhere else. Thank you all, and we'll see you again soon. Bye.
Thanks, everyone. Bye-bye.